Let's take a look at the game mechanics in the IO format here. So the customers arrive randomly to play the machine. The customers need to declare their intended playing time, and when the customer finishes playing or exceeds the time allowance, the next customer in queue starts to play. And for IO format, we have inputs, customer ID, priority, arrival time, and the desired amount of play time. And output, we have current time and current ID. The baseline scheduler takes round robin as our main algorithm, with no priority and the same time allowance for everyone. And just as in real life, the waiting queue for customers should be first in, first out. So let's look at how does this algorithm really works. First, we need to store the randomly generated arrival event. Since the machine starts unoccupied, the first customer on the list gets to play. Every customer after that will only get to play if the previous customer finishes the game in their declared time or exceed the maximum time allowance. The priorities are ignored here.
The second part is how does the algorithm work. In this project, round robin is the main algorithm, a method of selecting all elements of a group equally in reasonable order, from the top of the list to the bottom, and then from the top of the list, and so on. For each customer allocate the same time, and you don't need to record the stance of all correct connections, so you can use least time. First, judge the status of the machine, whether it is empty or if there have someone using the machine. If a customer is using the machine, judge how much time it has run this time, and update the remaining time of the customer. If the machine is empty, if there are customers waiting to be used, the first customer in the queue will be processed first. Calculate the end time at the required time to keratin time, and then update the time. Ensure that each customer is carried out in order.
Comparing with other data structure, Q has quicker response speed than others. The data structure below Q in left figure are not under consideration because we are searching for easy structure to implement. As for array, it is slower than Q in insertion and deletion, which plays an essential role in this project. So we could only choose our data structure between Q and stack. The primary difference between stack and queue data structure is that stack follows last in first out, while queue follows first in first out data structure type. And as for the advantage of queue, it provides a first in first out storage method, fast addition and allows repetition. And as for the drawbacks, it can only be added at one end and obtained at the other end. And access to other items is very slow. But in this project, the shortcoming can just be ignored, because we won't involve inserting players in the middle of the queue. The three charts below show that how we choose parameter. We choose 8 as parameter because it is the parameter that most minimizes the values of the 4 criteria.
This section is about pros and cons of baseline algorithm. Firstly, the algorithm is easy to apply, as user only needs to input the names of input and output files in the correct format. Secondly, the algorithm meets every customer's playtime demand, which enables customers to spend their desired time on the machine. The algorithm also has some problems. Firstly, the baseline algorithm ignores the priorities of different customers, which make high-priority customers to wait longer in sometimes. Secondly, the time allowance is a fixed value in the algorithm, which means every customer has to leave the machine when the time allowance is reached, and this makes the switches become unstable in the schedule.